Problem 6. Find the solution to the differential equation dy dx equals x cubed plus 2 over 3y with the initial condition y of 6 equals negative 5. Right, hopefully remember that if we have a differential equation and we want to solve it, definitely the first step that we are going to do is cross multiply. So we will get 3y dy is equal to x cubed plus 2 dx. Now I notice that I've got all the y's on one side and the x's on one side, so we can go ahead and take the integral. On the left side, the integral of 3y would be 3 halves y squared. And then on the right side, since there's a plus sign, we can really just treat this as two separate integrals. So the integral of x cubed would be 1/4 x to the 4th, and the integral of 2 would be 2x, and please do not forget that plus c. Alright, so now if we want to get the y by itself, to get rid of the 3 halves, let's just multiply everything by 2/3. So we'll get y squared equals 2/3 times 1/4 would be 1/6 x to the 4th plus 2 times 2/3 would be 4/3 x plus c. Now before I try to get the y by itself, I am going to go ahead and use my initial condition to find c. So since y is negative 5 squared would be 25, and then equals 1/6 times 6 to the 4th plus 4/3 times 6 plus c. So I'd have 25 equals, if I have 6 to the 4th over 6, that's going to give me 6 to the 3rd, which is 216, plus 3 goes into 6, 2 times 4 is 8, plus c, so I'm going to get 25 equals 224 plus c, and so c, if I subtract 224 from both sides, I'll get negative 199. So now I have y squared equals 1/6 x to the 4th plus 4/3 x minus 199, and then to get rid of the square, we're going to square root both sides, and usually we put plus or minus, and if I look at my initial condition, I know that I need to get a negative answer, so I'm going to choose the negative. So I'll get y is equal to negative square root 1/6 x to the 4th plus 4/3 x minus 199. Okay, problem 7. What is the slope of the line tangent to the curve y equals arc sine of 3x at the point at which x equals 1/9? Okay, two things here. First of all, slope means derivative. And then the second thing, if we have arc sine, we just need to remember what the derivative of arc sine is, which is du over the square root of 1 minus u squared. Right, and this will be our u. Okay, so my derivative is going to be du. The derivative of 3x would be 3 over the square root of 1 minus u squared. 3x squared would be 9x squared because you have to square both of them. And now we just need to find it at 1/9. So y prime is equal to 3 over square root 1 minus 9 times 1/9 squared. And so I'll get y prime equals 3 over the square root of 1 minus, well, if I have 9 over 9 squared, that's just going to leave me with 1/9. And we are not allowed to have a complex fraction, so here we go. Down below, this would really be like 9/9 minus 1/9, which is going to be 8/9. So I'll have 3 over the square root of 8/9. And if you recall, we've done before, we're going to separate that, so it's going to be 3 over the square root of 8 over the square root of 9. And we know that the square root of 9 is 3, so this is going to be 3 over the square root of 8 over 3. And if I have, this could be 3 over 1. If I have a fraction divided by a fraction, we're going to multiply by the reciprocal. So multiplying across, 3 times 3 is 9 over the square root of 8. If you also wanted to rationalize the denominator, another acceptable answer would be 9 square root 8 over 8, but both of those are fine. Okay, 8. If f of x equals e to the ln x squared minus 8, then f prime of 3 is equal to what? Again, this involves taking the derivative, and I need to know a few things here. First of all, the derivative of e to the u is e to the u du, and then I notice that this is going to be my u, and I have an ln. So if I know that y is equal to ln of u, y prime is equal to du over u. And these are just formulas that you have to memorize again, so try to get them out of your memory there. So now we're going to have f prime of x is equal to, so e to the u du. Okay, my u was ln x squared minus 8. My du is going to be du over u, so in this case this is another u. We'll get 2x over x squared minus 8. So if I'm finding this derivative, I'll get e to the u, which is ln x squared minus 8, times du, which is 2x over x squared minus 8, and I could try to simplify that if I wanted to, but I just need to find f prime of 3, so I'm just going to plug in 3 without simplifying it. Okay, so if I put 3 squared in there, 3 squared is 9, minus 8 is 1, so I get e to the ln of 1 times 2 times 3 over 3 squared minus 8. Ln of 1 is 0, e to the 0 is 1. Up top, 2 times 3 is 6. And then 3 squared is 9, minus 8 is 1. So 1 times 6 is 6 for that one. Okay, number 9. The rate of change of the area A of a figure with respect to time t is directly proportional to the cube root of the area. Which of the following is a differential equation that describes this relationship? First of all, they're talking about the rate of change of the area, which is a derivative, so I know my equation has to start with dA dt, which means I can automatically cross off A and B. So now I just need to notice, in C and D they both have a K, so I'm not going to be real worried about that. One has the cube root of T and one has the cube root of A. We just need to figure out which one of those I should use, and this one says the cube root of the area. So I'm going to pick the one that has the cube root of the area, which is choice D. Great, number 10. The function f has the property that f of x, f prime of x, and f double prime of x are positive for all real values x. Draw a possible graph of f. So we just need to decide what that means. Okay, if f of x is positive, that means the y values are all positive, which means the graph will always be above the x-axis. Okay, when it's talking about f prime being positive, that just means my graph is always going to be increasing, because that's what the derivative tells us about our functions. And f double prime tells us about the concavity. So if f double prime is always positive, that would mean my function is always going to be concave up like a cup. So if I go to graph this, I need to have a function where the graph is always above the x-axis, it's always increasing, and it's always concave up. And the choice that I would think of would be something that looks like that. Because it's going up, it's definitely concave up, and it's above the x-axis.